Hello students and welcome back to the mathematics class. We are doing the chapters basic geometrical ideas and in the previous class we understood some terms like points, line segment and the related concepts. And I hope you understood the previous class properly and still you have any doubt just write down the doubts anywhere so that in the live class we can have the discussion. Okay. So now today we are moving to the next concept of the chapter and the topic we have today is curve. So we understood the meaning of line segment, straight line, whatever, and now we are going to the next part that is called curve. And to understand this concept, let's take a simple example. That is, we are having two different points, x and y. Okay, and someone has to move from x to y. That is, you have to move from x to y point. So what are the different ways by which you can go to y? So the very first possibility is you can follow any other path and come to y. This is one way. You can go through this long way. This is another possibility. Third possibility we have, you go very long path and then come back. So these are the different ways, and I think we have infinite number of possibilities by which you can move from x to y. But you know, if you talk about this particular path, for example, I am talking about this path x b y. So if you are traveling on this particular path x b y, it understood this path is quite longer as compared to this and this one. So overall, if you have to move from x and y, the shortest path will be what? So if we directly connect the point x and y straight away, x to y directly, then we'll get a straight line, and this straight line is nothing but showing you the shortest distance between x and y. So overall, other than this xy straight line, whatever you see on this diagram is nothing but a curve. So we can say we got first curve here, we got second curve here, we got third curve here. So we can say curve is nothing but a line other than a straight line or straight line segment. So if we talk about this particular line, x to y straight line, it is straight line and a line segment as well, because it has two endpoints x and y. And other than this, whatever path you are able to see are nothing but the curve. So we can say curve is nothing but a straight line, a line other than a straight line. So straight line or line segment. So briefly I am repeating again. If you have two different points x to y, x and y, if you have to move from x to y, we can follow a different path. I can move straight away, that is on a straight path. And when you are moving on a straight path, you are basically talking about you are moving on a particular direction, fixed direction. But if you follow other path, that is other than the straight line, you see you are basically moving from x to y, and in between you are changing your direction also. So at this point you are facing this direction. When you come here, you are facing somewhere this direction. When you are here, you are facing this direction. When you are here, you are facing this direction. So on the curve, almost different number of times you are going to change your direction, but on a straight line you keep moving on a same direction, and that is another difference we can find out between the curve and a straight line. So I hope you understood a line other than a straight line or line segment is a curve. So this is a simple definition we can talk about. And now let's take another diagram. So for example, x to y is one of the curve, we can say. This is also another curve, because now again you are going to change your direction here. So even if once you are going to change your direction where you are moving from one to other point, means you are basically moving on a curve. Okay, so it is possible that a curve itself can be made up of line segments. So we can say x to a is a line segment, a to I is a line segment. But when you talk about x to y, that is entire path, then it basically become a curve. So we can say it is possible a curve can be made of line segment. So it's not like in a curve you cannot have a straight line, you cannot have a straight line segment. It is possible, but even if you are going to change your direction once, means anywhere if you see a bent portion, you are basically going to talk about a curve. So I hope you understood. This is also a curve made up of two different line segments. It is also a curve, it is also a curve, and more examples I can show. Okay, so I hope this much is clear to you, the meaning of curve. And now we are going to the next thing, that is called simple curve. Okay, so to understand this, again we'll take the help of the diagrams only. I am making two different diagrams. This is x to y again. Okay, this is one curve that is between x and y, and let it be given a name. This is 1, and another take x to y, and this is also curve. Okay, so let this be number 2. So when we are talking about curve, it's not having a particular shape or size, no, anything can be drawn, and both 1 and 2 are basically curves, but you are able to see some difference. And the basic difference you see here is, if you talk about number 1, x and y, that is this curve, you see this line is not crossing each other. So overall it started from x and moving to y. In between there is no cross, means the line itself is not crossing anywhere. But here if you talk about this particular curve x to y, you see at this particular point, what you see, the line will cross each other, means line is crossing each other. So if we have a curve in which the line will cross each other, or the line will cross itself somewhere, then it basically a different type of curve as compared to the first one. So the first one is called a simple curve in which the line will not cross anywhere, and if the line will cross each other somewhere, then it is not a simple curve. So I hope you understood. This is your simple curve, means the line will not cross anywhere, is a simple curve. So examples can be this one, x to y. It can be this also, x to y. So you can draw any kind of shape, but you have to remember the line which you are drawing, which is a curve, should not cross anywhere. That's a simple meaning of simple curve. Otherwise, if it will cross, it will become a different kind of curve. Okay, so I hope you understood the meaning of simple curve also. Now the next thing we have is open curve and closed curve. So again, with the help of the diagram, we can understand it. So let's talk about x to y. So this is a kind of curve only, and I'm making another one. Okay, so whatever. So if you see, this is again number 1 and this is again number 2. So I hope you are able to differentiate somewhere with the help of the diagram. The two different curves are not same. What do you see here? The first one, you started from x and coming to y. So overall we can say it as a starting point and it has a ending point also. So it has got x as starting point, we can say. Just take an example. And this is nothing but end point. So a curve in which there is a starting and end point, okay, and these 2 points are not same. So we understood x and y, they are two different points, and if these 2 points are not same place and the points are not having the same location, then we are basically forming a curve which is called open curve. So I am repeating again, if a curve is having the starting and end point such that the two different points will not come together, will not intersect each other, will not meet together, will not coincide with each other, such a curve is given the name open. So you can see this is quite open. And closed curve, you're not able to find anywhere the starting and end point. So you don't know from where you started, from where you end. But overall, even if you talk about the starting and the end point, so once you started from here, for example x, so you started from here and you move to this direction, and finally come back to where x1. So overall, we can say here the starting and end point are the same, and here the starting and end points are different. So based on this, we can define and differentiate the open and closed curve. So this is your closed curve in which in general there is no starting and ending point, but still if you talk about starting and ending point, these 2 points are same. For example, x is the starting or ending point. Just for example, I can take any other point, y. So we start from y, we'll come back to y. If we start from x, we'll come back to x. So anywhere we can think of any point, and that will become the starting and end point both, because overall we have to complete the path. So I hope you can differentiate. So this is your open curve and this is your closed curve. So I hope you understood the meaning of open and closed curve. So a simple definition we can say, a curve which has start and end points, we can say end points which are not same points is open curve. Okay, so we can draw anything x2, y. So x and y are two different points which are not coming together, and the curve you see is basically an open curve. Okay, so I hope you understood this one. And second thing we can say, that is a curve which has no start or end points, or we can say, or have the same start and end points, is closed curve. So I hope you understood this concept. So if you talk about, for example, you started from x, you came back to x. So overall the starting and end point are same, it's a closed curve. You started with x, again you came back to x only. So that is how we can define. Overall there is no starting and end point, but even if you define a particular point from where you started, so you'll come back to the same point. So starting and end points are same. So second definition is also correct. Or in general we can say there is no starting and end point for a closed curve. So that is how the difference comes. Now if you're talking about a closed curve, now the closed curve can have some related concept, and that is the second thing we have is simple closed curve. So again we need to understand this. I hope you understood somewhere the meaning of simple curve. You understood. Now if you talk about simple closed curve, you can understand here. So again I'm making two different closed curve. Again I'm giving the name 1 and this is number 2. So I hope we are able to differentiate the two different curves now. Both are closed, that is understood, because here also we don't have any starting and end point. Here also we don't have starting and end point. Or even I say started from here, then you are coming back to the same point. If I started from here, you are coming back to the same point. So both are closed curve, but again you see the difference. In this curve, again the line is not crossing anywhere. But you see in this particular diagram, the line is crossing here, the line is crossing here, the line is crossing here. So if I give the name x, y, z, so there are the 3 points at which the curve is basically crossing, and that curve is nothing but a non-closed curve or non-simple closed curve, and this curve is basically called a simple closed curve. So basically we are talking about this, a curve which is having a line which is not crossing each other anywhere. So that is simple concept we have. So this is not a simple closed curve, this is your simple closed curve. That is, the line will not cross anywhere. So we can say a closed curve in which the line does not cross anywhere. So I hope you understood the meaning of closed curve and simple closed curve. Okay, so we can take some different diagrams for it also. So even I draw this one, you can see it's a simple closed curve. If I draw this one, it's a simple closed curve. If I draw this one, it's a simple closed curve, because nowhere you see the line is crossing anywhere. Okay, so I hope you understood the meaning of simple closed curve also. And now the next thing we have is parts of closed curve. That is also important. Means when you are talking about a closed curve, it can also have some related terms. That is also to be understood here. Just take an example. I am making any closed curve. Okay. So now this curve is on a plane that is on my board now this time, and now we can find out 3 different points. Overall we have infinite number of points, but 3 different space we can find out. One thing is any point which is inside. So let this point be A. So we can say A is within the curve. We are talking about B, a point which is outside the curve, that is closed curve. And we are talking about a particular point C, which is where, which is on the line which is dividing the A and B space. So overall we have one space inside of the curve, we have one space outside the closed curve, and we have one line which is dividing the inner and the outer space. So overall A, B, C are given 3 different names. Okay, so your A is called interior of closed curve. So A is a point, but we are talking about the entire space. So the shaded portion that you see here is your interior of closed curve, and A, I can say a point in interior of closed curve. So such points we can have infinite. So all the dotted you see here are nothing but the points which are within the interior of the closed curve. So when you talk about interior, we are talking about the entire space, entire area. So the shaded portion, the entire shaded portion is basically your interior of closed curve. And then we have a point B, which is outside the space. So we can say exterior, or we can say again a point outside the curve. Okay, and the space is exterior. So I hope you understood the meaning of interior and exterior. So interior is within the curve, whatever space we have. A is within the space, interior space. B is another point which is in the outer space, and that space is called exterior space. And the point C is on the line which is dividing the interior and exterior space. So this line is called boundary. So we can say a point on the line dividing exterior and interior of space or closed curve, and this line is called boundary. So whenever we are talking about a closed curve, we'll have three different terms. One, we understood the interior space, one is your exterior space or external space, and one is the line itself which is dividing the interior and exterior, and that line is called boundary. So we have interior, exterior and boundary that we need to understand here. So I hope you will be able to differentiate the space given to you. So if I draw any diagram, so we can say this is your entire space, your interior space, this is your exterior space, lots of space we have outside the curve, and this line itself that you see now dotted is nothing but your boundary which is dividing the interior and exterior. That is simple concept we have. Now we are moving to the next thing, that is we have, that is called polygon. So since now we understood the meaning of closed curve, and the closed curve has lots of importance in mathematics, and now we are moving to the next part of the closed curve, that is called polygon. So overall polygon is nothing but any closed curve. So just remember, polygon is nothing but a closed curve which is made up of straight line segments only. So you can see I have made one closed curve, and you can see overall this is one line segment, line segment, line segment, and all the three are straight line segment. So if a closed curve is made up of only straight line segments, it is basically called polygon. Okay, so we can say this is one of the polygon. Second, I can draw this way, but you have to remember the line should be straight. I may not be able to do this time, but when you do with the scale, you get a straight line only. So this is another polygon with how many straight line segments? You see 1, 2, 3, 4. I can go on dividing it as many as possible. So now what you see, another polygon which is made up of many line segments, 1, 2, 3, 4, 5, 6. Okay, so we can have polygon of different number of line segments, and based on the number of line segments we have, different names are also given to the particular polygon. So one thing is understood here, polygon is nothing but a closed curve, first thing, and the meaning of closed curve we understood. Second thing is that closed curve must be made up of only straight line segments. So we see all the three examples on the board are made up of straight line segments. And third thing is, if it is a polygon, then based on the different number of line segments, we have different names are also given. So that we'll understand in the next class. Okay, but in general you should know the minimum number of line segment that we need to form a polygon is 3. So you can see, if I just have 2 line segments, it can only form a open curve. It cannot be a closed. To close this curve with the help of line segments, we need at least 3. So we can say this is the shape or a polygon which is having minimum number of line segments. Okay, that is also given a name called triangle. Okay, based on the different number of line segments we have, the different names are given, and that will be the topic of the next class. Today we are not going to discuss the different types of the polygon. We have understood the meaning, I hope, the meaning of polygon. So we can say a closed curve which is made of straight line segments only. Okay, So that is understood now, and different examples I have already shown to you. And now since we understood the meaning of polygon, now again we'll go for the different parts of the polygon, and then your topic will be done for today. So let's talk about parts of polygon. So for this, let's take any one example of polygon. So 1, 2, 3, 4. So I haven't drawn the straight line properly, but you should remember the lines should be straight and you must do with the scale only. And now what you see, this is 1 point, this is another point, this is third point, this is fourth point. And let's give name to different points: A, B, C, D. So we have a polygon of 4 number of line segments. Okay, that is A to D, A to B, B to C, and C to D. Okay, so these line segments that you see in a polygon is given the name called sides. So very first, sides of polygon. So only with the help of example you can understand them. So we can say the line segments which are basically forming the polygon are given the name called sides. So line segments forming the polygon. So that is called sides. So how many sides we have here? 1, 2, 3, 4. So we can say here we have A, B, one side, and you know how to show the line segment. AB, then we have BC, then we have CD, and the last we have DA. So you can give the name anyway. AB can be written as BA also, CB, DC, DAD. But overall, AD and DA are same. CD and DC are same, BC and CB are same, AB and DA are same. I hope you understood the sides meaning. So you can say here we have 4 number of sides. Okay. Then next we have number 2 part of this polygon, that is called vertex. So overall the points which are visible here, the points which are given A, B, C and D are points which are basically connecting 2 different sides. So you can see with A, AD is connected, AD and AB are connected. So we can say A is a common point of AD and AB. Or you can say the point which is connecting the 2 different sides of a polygon is nothing but a vertex. So I can say the point connecting two sides. So 2 sides of polygon. So how many vertex you can see? 1, that is A is connecting AB and AD. D is also connecting D and DC. C is connecting CD and CB. And B is connecting BC and BA. So overall A, B, C, D are 4 different vertex or vertices. So that is understood here. So we can say A, B, C and D are vertices. That is the plural of vertex. So I hope you understood the meaning of vertex also. That is any point which is connecting the 2 different sides of a polygon is a vertex. So again, based on the number of sides, we'll have different number of vertices also or vertex also, that you have to remember. So that will change. So this is just for example I've taken, but we can have different types of the polygon also. Next we are talking about adjacent sides. So we are just talking about adjacent sides of polygon. Okay, so I'm not writing that much, but remember. So adjacent means next to next. For example, you talk about AD. Next to AD, what we have? AB, and next to AD we have DC also. So we can say here AD and DC are next to each other. So these 2 are adjacent sides. AD and AB are also next to each other. They are also called adjacent side. AB and BC are also adjacent sides. BC and CD are also adjacent sides. So any 2 sides which are next to each other are basically called adjacent sides. Or we can say the two different sides which are connected with the common vertex. So you can see D is the common vertex of AB, AD and DC. D is the common and C is the common for CD and CB. So based on this we can define anyway. So we can say two, or say we can say the sides or the pair of sides which are having a common vertex. Okay, so pair means two, AB, AD are two different sides next to each other. So for example, we can say DA and BA. This is one adjacent sides. Then we can have DC and BC. Second example. Okay, so these examples are different, don't be confused. We can have AB and CB also. AB and CB. So I hope you understood. Next to each other, whatever you see, these two are adjacent sides. So this is adjacent to each other, this is adjacent to each other, this is adjacent to each other. So I hope you understood the meaning of adjacent sides also. Next we have, that is called adjacent vertices. So how you can understand the concept easily now. So we understood the meaning of adjacent, that is next to next. So now we are talking about the vertex. So next to A we have D. So we can say A and D are the adjacent vertex or vertices. A and B are also next to each other, so they are called adjacent. B and C are also next to each other, adjacent. C and D are also adjacent. So we can say a simple word, that is overall CD is nothing but a line segment, and C and D are the different end points of the line segment. Okay, so we can say the end points of a given side, because CD is also a side. So we can say the end points of a particular side of a polygon is nothing but the adjacent vertices. So we can write down, that is the end points of any side of a polygon. So I hope you understood. That is AD is one of the side, and A and D are the end points of this line segment and the side also. For A and B, A to B, that is nothing but a side of this polygon, and A and B are the two different end points of this AB. Say B and C are the end points of this line segment BC or the side BC, and C and D are the end points of side CD. So the examples we have are A and B. This is one next to each other. D next to each other. Then D and C next to each other. C and B next to each other. So I hope I have covered all. A and B, A and D, D and C, and C and B are different adjacent vertices of particular polygon. So again, based on the number of sides of the polygon, the number of vertices will also be different. So the main thing is you should be able to find out. Okay. And the last term we have is, that is called diagonal. Okay, so any polygon will have a diagonal also. So again, try to understand the concept here. So now if I connect A to C, what you see, you get a straight line. Okay, and this straight line is basically connecting the two different vertices of this polygon A and C. But you see, A and C are non-adjacent vertices because A and C are not next to each other. So AC is one of the line segment which is connecting two different vertices which are non-adjacent, and such a line segment is basically called diagonal. So first I am writing the meaning, that is the line segment which connects any two non-adjacent vertices of a polygon is a diagonal. So here example I've shown to you, that is the first one is AC. So AC is one of the diagonal because A and C are non-adjacent. Now I can connect B to D also. So B and D are also non-adjacent, and the line connecting B and D is basically called another diagonal. So we can say AC and BD are only two possibilities we have. That is, only two diagonals can be made in this particular polygon. But again, with the change in the number of sides of the polygon, the number of diagonals will change. So I hope you understood. That is, BD and AC are two different line segments which are connecting the two different non-adjacent vertices of the polygon, and these line segments are basically called diagonals. So I hope if you see the polygon, you can differentiate all the terms. That is, what you mean by vertices, vertex, sides, non-adjacent, adjacent, and the diagonal also. So I hope you understood, and that is all we have today. The topics, that is, overall we understood the different meanings related with the curve, the meaning of curve, then open and close curve, simple curve, then simple close curve. We understood the meaning of polygon and also the different parts of the closed curve. So I hope you are able to understand and you can apply this in the exercise also. So today I'll be just doing one question from the exercise that we have next, that is exercise 4.2. I'll be just doing the number 1 and then rest you will take as a homework. So we have to classify the following curves as open or closed. So overall different diagrams are given and you have to find out the curves are open or closed. So open or closed curve. So that we have to find. So number 1 diagram is given to you is this. So you understood? If you say this is your starting point, so this will be your end point. So you are able to find the end and the starting point, so it must be a open curve. So there is no doubt here. This way you have to think, okay? Number 2 is given to you. It is something like this way. So I hope you understood. Again, you start from anywhere, you come back to the same point. So it's also nothing but a close. It's a closed curve. So no doubt. If you start from here, you come back to the same place. If you start from here, come back to the same place. If I start from here, you come to the same place. So it's nothing but a closed curve. So here your starting and end points are same. Number 3 diagram given to you. Very simple. That is something like, so I'm not making proper diagram, but something like this. So again, you understood? You started from ABX, you came back to Y. Again, the end points are different, or we can say the starting and end points are different. So you understood there is nothing but open curve. So think in this way. Think in this way. That is, if you are able to find the starting and end point, and if these 2 points are not same, it is open. Otherwise, it is close. And the last one is not last one. 2 more we have. D. I've already done for you. So this you understood, but it's a closed curve because there is nothing but a triangle. I've already said. So again, this is your closed curve. And one thing you can take as a homework, that is, if you are given a triangle, can a triangle have a diagonal? Because we understood the meaning of a diagonal and polygon has a diagonal. So just find out if this triangle has a diagonal. So I'll take the answer in your right class. And the last one is something like this. So it understood. Again, you start from anywhere, you'll come back to the same. It's a closed curve. So this all, and this chapter is very simple, not so difficult. So I hope you understood these questions now, and since you have understood the meaning of open close curve, you can easily do all the questions. So there is to do as a homework, that is number 3, 4 and 5. So number 3, number 4 and number 5 take as a homework. So for today the class is done. The only thing is you must take care, that is whatever notes are given to you, don't copy the notes, only do the exercise questions which are given to you and the homework which is given to you in the notebook. The rest notes are just for you, for your help, so that you can read out and you can understand anywhere, and you must go through the video lecture properly so that you can have a better understanding of the concepts, because all the things cannot be understood with the help of written notes only. That's why we are making the video lecture also for you. So I hope you understood the class today, and just wait for the next class. For today is done. Take care, be at home. Thank you, and Hari Om.